Okay, so we have a question right here. It says that a student applied a force F to a rubber band. The student measured the corresponding extension X, delta X, as F was increased and then decreased. Okay, the graph shows the F, which when it was increased and decreased, the force increasing and decreasing, and what is happening to the rubber band when the force increases and decreases. State how the graph shows that the rubber band deforms elastically. So in other words, they're basically asking you, like, you need to just tell them what is happening from this point to this point, right? So you just tell them when you remove the force, it's just basically going down to its original length, right? So it's very simple. So you write when the force is removed, the rubber band goes to its, sorry, to its original length. So you just simply have to describe this process right here. And yeah, that's your final answer. Okay, so the next part says that the work done on the rubber band as F increased is greater than the work done by the rubber band as the F was decreased. There's a difference in these values because heating is occurring. Okay, remind the energy that caused the heating as F was increased and then decreased. So before we solve this question, I want to explain you something in this graph right here. So let's forget these lines and I will draw a new line. Let's say this is your line following Hooke's law. And then when I ask you what is the energy for this, the elastic strain energy, right? So you will say it is the area under the graph, right? Which is basically this right here, okay? And it's the same thing for the decreasing force as well. Now, what they did is basically made an increasing force and a decreasing force as well, right? So they told us that if you focus clearly, right, they told us that the work done is greater when the F increased and the work done is less when the F decreased. And this is because the heating is occurring, right? So basically, and they mentioned the main important part, energy, right? So where do we get our energy? From area under the graph, right? And if we combine these both, right, this is the heat occurring, or in other words, the energy, right? This is your energy right here, but in the heat form, right? So now we have to just calculate this and give our answer. So how we will calculate this particular graph, right? How we will know how much is this exactly? So one of the easier way is that, let's say this is your box right here. So if you can see, this is 0.5 centimeter. Make sure to convert your units into meters. So it will be 0.005 meters divided by 100. And then this is your 0.5 newtons, right? If you multiply these two together, you will get 0.5 times 0.005. So you will get 0.0025, and it's basically, I think, joules. Yes, joules. Okay. So your one big box is basically 0.0025 joules, right? So make sure you write this as well, telling your scale. What scale are you taking? I'm taking as one big square, right? Which is 0.5 newtons times 0.005 meter, and it will be 0.0025 joules. Okay, so you told them your scale, right, from where you will be measuring. And then let me remove this again. Sorry. Now we need to calculate this, right? So one of the easier method is that, first, because as you can see, this is not a whole box right here, right? So the one of the easiest method is first get the large box first, like the complete box. So this is one complete box. This is the second complete box. This is third, fourth, fifth, and sixth. And you can say this is seventh, right? So you have 7 complete boxes, right? Now, once you got the 7 complete boxes, 1, 2, 3, 4, 5, 6, 7. Now you have to do a lot of estimations. Don't worry. They have given a range for the energy value, for the heat energy value, as everybody cannot have the same answer, right? So now let's say, for example, we take this box right here, this exact box right here. Let me zoom in, right? So this box exactly right here, let me draw a red color, this box, okay? And if we take this box as well, you can see, like, if we combine these two pieces together, you can see it almost makes a whole one box, right? So you have to do all of this same thing with the other boxes as well, right? And sometimes there will be like, you need to use one piece for at least three boxes, right? So let me show you an example. I have already did this for you so that we don't waste our time. So let me remove this, and there you go. Okay. So for example, there's one example right here. I made one example here. So as I was counting, this box could fill up this 11, 12, and 13 to get all three together, right? So I use half, 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 half. Sometimes this thing will occur as well, right? Where you can't match two pieces, so you will use one small piece to combine at least two pieces, right? Complete two pieces, right? So this big piece completes 11, 12, and 13, right? So you have this complete box right here. You don't have to be accurate. You just have to make some estimations, right? Because you will have some errors in while calculating these stuff, right? So it's the same thing. Now, for now, I got 20 boxes. Maybe you will get 90. Maybe you will get 19.5, something like that, right? So I got 20 right now. So all boxes together, wait, sorry, all boxes I got is 20. So now I will multiply this 20 with this so I can know how much the heat energy is being, like how much the heat energy is caused. So 20 times 0.0025, and basically this gives me what? 0. I think it was 0. If you remove 10, now you're left with 0 0.0. Let me check as well from my calculator. Yes, it's 0.05. Okay, so it's 0. My bad, 0.05. Okay, joules. So there is a range given. I actually don't remember what was the range, but you can see from the mark scheme they have given something from 0.0457 blah 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 to 0.05 something. I don't know the range, but this is the range. And if you get your answer within this range, then you did like correctly. If not, then you must have done something, like calculating extra. Maybe going, for example, you're going for a one box and you're taking some extra piece. There might be some a little bit more extra piece, and then you put it, like for example, a lot bigger piece. Like for example, let me show you. If I take this piece and just try to fit this piece, right, in here, and that will be like, unfair, right? So you don't have to do that. Try to, like, break it into more smaller pieces and combine it, like for example this thing right here, combine it with the all of these three pieces, right, to 11, 12, or 13, right? So this is how you will do this particular part. So this is your final answer.